So we have ionic bonds, we have covalent bonds, we have polar covalent bonds, and the last one is a hydrogen bond. The difference between a hydrogen bond and all other bonds is that this bond is representing almost like a force between hydrogens when they're near each other. Now remember, hydrogen is the only atom that doesn't have a complete shell one. It is an atom with one proton, one electron, so it only has one electron on its first shell, so it's very unstable. It's constantly reacting. So although hydrogen reacts with water, it forms a polar covalent bond. So there's still kind of, and let's remember who's winning the pool? Oxygen. So hydrogen is still kind of like hanging off. So that hydrogen starts to make this force between the other hydrogens of another water molecule. So here's water molecule number 1, H2O. Here's water molecule number 2. And these hydrogens they create a force and the bond forms right here. Okay? The bond forms between one water molecule and another. And it forms between the oxygen of one and the hydrogen of the other. This is the weakest type of bond. So it's constantly breaking apart and coming back together. So this bond is why water has unique properties. And I'm going to talk about these unique properties. Before we talk about the unique, yes. So you could better understand this attraction, okay? What happens when you're in a restaurant and your cup of water kind of lets water onto the table, and I'm sitting right across from you and your cup has a little bit of water condensing from the cup onto the table. Do you know? Well, yeah. It went through condensation and liquid water forms on the table on my end and liquid water forms on the table on her end. What happens to the water? Anybody know? Have you ever watched water on your table? I guess I'll pause the. They start to connect. That one drop becomes a bigger drop and a bigger drop and a bigger drop because that attraction brings those molecules together. It is why we have oceans and lakes, because water looks for other water and they connect together. This is what a hydrogen bond is like. One water molecule, let's circle it. One water molecule gets connected to another by O of one molecule, H of the other. Okay? Even though it's weird because they're called hydrogen bonds, it's really water molecule connecting, and it's one O to the H. Did I just answer your question? Yeah. Now, let's talk about water for a minute, and then we're going to understand this property a little more. Anybody know how much of Earth is water? 70-ish, right? How much of you is water? 70-ish. Because remember that all living things try to maintain homeostasis or balance. If we had more water than Earth, we'd constantly be losing water. So when you drink lots of water, you lose water. When you're dehydrated, your body asks for water because you're maintaining that balance with Earth. This is just the way it works out. Same thing with your cells. Your cells are 70% water. Now, water is made up of 2 hydrogens and 1 oxygen. Each hydrogen shares 1 electron unevenly with oxygen, and that is the explanation of what type of bond? Polar covalent bond. Right now, remind yourself that you're going to get this wrong on the test if you don't remember that between one water molecule, the 2 hydrogens form a polar covalent bond with the oxygen. The hydrogen bond talks about bonding between 2 water molecules. 1 molecule of water, each hydrogen shares electrons unevenly with oxygen. The hydrogen has a positive end and the oxygen has a negative end. you're going to have to draw this molecule on the test. You're going to have to show me that water has 2 hydrogens. You're going to have to show me that water has 1 oxygen. You're going to have to show me that one end is slightly positive and the other end is slightly negative. Yes. Will you give us the test? Periodic table. Correct. That is the only piece of information I give you. And it'll look exactly like the one in your notes where the top number is the atomic number and the bottom number is the atomic mass. And the element is in the middle. Yes. So there's specific things that you might not understand, but there's specific things that I'm always going to tell you. I'm telling you that water forms a polar covalent bond. I'm telling you that the hydrogen is positive and the oxygen is negative. And the reason you know that is because they are sharing unevenly. And I'm telling you, the hydrogen becomes positive and the oxygen becomes negative. The winner of this pool is oxygen because it's taking from the hydrogen a little bit. And you know this because when ionic bonds form, the atom that gets the negative charge is taking the electron. In a polar covalent bond, nobody's taking anything, but they're pulling. Remember I showed you the dogs yesterday. Think of this electron as a bone, and this one, and the oxygen is pulling tighter.
So, it's an uneven
sharing.
Because oxygen has more.
That's a good answer, but it doesn't always work that way. Okay? But water is the perfect example of a polar covalent bond. That's going to be on the test. And oxygen pulls, becomes slightly negative. Hydrogen is losing the pull, becomes positive. Or describe the molecule of water. Why is it positive? Why is it negative? Could be a lot of things. And I'm going to give you one assignment of the dissociation of water so you could see it coming together and pulling apart. The same way we did with the ionic bonds. I told you on the test, you will have to give me an example of an ionic bond. That's why you're making one right now. And you might have to give me an example of a covalent bond. That's why you're making one. A polar covalent bond is kind of in between ionic and covalent. Okay? Keep asking questions. They're never wrong. All right. So this is a reminder. What's a hydrogen bond? What does it form between? I already taught it to you. I mean, if not, look at the video. What does the hydrogen bond form between? The H of one water molecule and the O of another. So that's all you're filling in here. The H of one water molecule and the O of another. Or the O of one water molecule and the H of another. This bond causes that strong force that is like a magnet.
Does it matter here if you write like hydrogen and oxygen?
Nope. Doesn't matter. Because I could flip those around. I actually literally just bonded these together. And then I grouped them. Okay? All right. I'm going to stop here.